people, and then sunbathing. And although many people said that she looks dead in this photo, she was very relaxed and she was not dead. Finally, pet stalking our new bunny, and she was very upset and jealous that we have another pet. If there's one thing you can take away from these pictures of Pipette, is that Pipette is very emotional and she has a lot of emotions. Now, my question when coming into Science Friday was, can Pipette recognize my emotions? Because dogs have been domesticated and they have been integrated into human society. And furthermore, from whether dogs can recognize my emotions, I realized there was a lot of real world applications to studying dogs. For example, they're one of the only non-human interacts with humans a lot and has successfully done so. And there's also the role of evolution and how this has played into dogs being able to recognize our emotions. And there's a lot we can learn from their cognitive abilities. So I'm just going to give you context before introducing the paper. There's this concept called cross-modal sensory integration, and this is how the dogs would supposedly recognize human emotions. So it's where they use cross-modal, they use two sensory modes to recognize emotions, and by modes, I mean things like sight, touch, smell, etc. So for example, if you gave me a banana, I would see that it was yellow, and then I would eat it, and it would taste like a banana, and then I would be like, that's a banana. One example of how sensory integration works, but it can also be used to recognize emotions, which is a lot more complex. And it can be used to make analyzations and inferences by taking in kind of visual data and then kind of realizing something on a deeper level. And then why would it be useful? Well, it's really useful for a dog in the wild, maybe with its pack, to be able to recognize its pack mate's emotions. And then it can also be used for survival. Okay, so I'm just going to give a few points of context for the research paper. So cross-modal sensory integration has already been seen in species towards their own kind of animal. For example, a dog could recognize emotions in another dog using cross-modal sensory integration. But they didn't know if the dogs could do this with species that weren't dogs. They could do it with humans. So that's kind of what the study was testing. And it's known that dogs can see facial expressions, but there's no proof that they can tell oh, this is that emotion, or they can make any deeper analyzation other than seeing a sad or a happy face. So this is just the article itself. It's called Dogs Recognize Dog and Human Emotions, and it's published by the Royal Publishing Society. Okay, so now I'm going to get into the experiment by showing an example, and this is testing if dogs can recognize human and dog emotions. So I'm just going to walk you guys through a trial that they did, an example trial that they would do. So first, they had the dog sitting in front of a projector, and they would show two pictures in front of the dog. One of the pictures was okay, and also they either showed dog pictures or human pictures, because they're testing if dogs can recognize emotions in dogs and humans. But I'm just going to use dog pictures for this example. On the left is a dog being really happy, and on the right is a dog being aggressive. And then at the same time, they played a sound, and sound could be a happy, the sound of a dog being happy, or the sound of a dog being aggressive. So for example, if the sound were a happy dog sound, then what face would it match up with? Can somebody answer? Anya? Yeah, the happy dog, one on the left. The happy sound matches up with the one on the left, obviously. And then this is what the researchers defined as a congruent face. The sound matches the face here. And this would be a non-congruent face because the happy sound doesn't really match the aggressive dog face. And then the third part of this trial is that they timed how long the dog looked at each picture. And this was used to kind of quantify the data, because you can look at dogs looking at pictures, but you can't really make any analyzation from that. Okay, and then so this is the first figure that was in the graph, and it was basically the experimental structure and the way they set up the experiment. So this would be where the dog is. This would be the screen where they. Then this would be like the projector, like they play the sound, and there are two researchers in the front and back. Pretty simple. And these are just examples of like the human faces they showed. And these are just examples of like angry human faces and angry dog faces that they showed. And then these were examples of like yeah, and then yeah, the sounds were either positive, which was happy, negative, aggressive, or neutral, but we don't have that kind of negligible because it was just used for like okay. And then to quantify their data, they had to make a variable. And in this case, they made something called the congruence index. I'm going to explain what this means. Basically, they timed the amount of time that the dogs were looking at congruent faces where the sound matched up with the picture. And from that, they subtracted the amount of time the dogs were looking at the non-congruent faces because those were the faces where like the sound didn't match up with the picture. So it wouldn't, if dogs could recognize emotions, they wouldn't look at those faces. They subtracted that time, and then they divided it by the time looking at just like both faces. So yeah, basically to analyze that a little further, higher congruence index, it means dogs spent more time looking at congruent faces because the top part of the fraction would be like higher. And then if there's a lower congruence index or even like a negative one, the dog spent more time looking at like face congruent. So that would mean the dog is really bad at recognizing emotions, which is quite unfortunate. Okay, so finally the results. So in 2/3 of the trials, that's 188 trials, there was a clear preference for congruent faces. And that basically proves that dogs have a really easy time recognizing emotions. They're good at it because in the majority of the trials, they were looking at the correct faces. So the researcher hypothesis that the dogs could like use cross-modal sensory integration to recognize faces, like taking in the picture and then the sound and then using that to recognize faces, that was correct. So reinforcing that the dogs can recognize emotions. And then this is the average congruence index, which is 0 plus or minus 0.03. And the plus or minus is a confidence interval, which is, it's basically like a range. But yeah, it was above 0. And just a reminder that higher congruence index means that the dogs spent more time looking at congruent faces. So basically, dogs can recognize emotions. Yay, dog, it can recognize your emotions. Wow, that's great. Okay, and then finally, now we're going to take kind of like a deeper look into those results. So there were 4 main factors. I had like transitions on this slide, but I don't know why they just like disappeared. So this is just like all at once. But basically there were 4 main like variables in the trial that might have affected the results. So the first one was the species of the show, whether it was like a dog picture or a human, was like whether the sound played was like a happy sound or an aggressive sound. And then the third one was the sex of the animal, so whether the animal shown was like female. Then finally, the fourth one was which side the picture was presented on, which is left or right. And these are important because they could be like external variables affecting the results. But it's important to remember that like regardless of these variables, the congruence indexes were mostly positive, which means that like regardless of these variables, the dogs could still like recognize the emotions. So this is the figure that presents these 4 variables. Like each of these graphs represent one of those variables, and it's like take you through each of them. So this is the first one where on the x-axis is basically whether the picture shown was of a dog picture or a human picture, and the y-axis is the corresponding congruence index for those pictures. So in this one, as you can see, the dog, like the dog picture shown had a much higher congruence index than the human pictures. And does anyone want to like take a guess as to why the dogs were better at recognizing emotions than like dogs and humans? Oh, Eric. Yeah, that's right. So it's between 0.25 and 0.3, and then the human one is between 0.10 and 0.15. Okay. And then this is the type of sound played. And on the x-axis, there's if the aggressive sound was played, and then if the positive sound was played, or like the happy sound was played, corresponding congruence indexes. And the one for the sound that was played was much higher. So like, does anyone want to take a guess at that? A lyric? Yeah, that's a good. Okay, and then there's like the sex of the organism showed. So there are pictures where the organism was female, and this were pictures where the organism was male. And although there is a difference, it's important to remember that like the difference is actually that big, and overall like it's kind of hard to make any like analyzations from this graph because like these dogs don't represent, like in this context, the dogs don't necessarily present all dogs. So we can't really for sure say that like they're better at recognizing like female emotions than male ones. And then finally, this was like the side that the picture was presented on. And I think this is the one that makes sense to me. So these were when pictures are presented versus the right, and they're recognizing emotions in the pictures on the right. Does anyone else want to take a guess at why the pictures on the right were more recognized? Yeah?
Most dogs are like right-handed.
Yeah.
Right pod, so they gravitate towards things on their right more.
Yeah, right pod is such a cute term, I think. But anyways, okay, so now we're just going to discuss the results. So as a quick summary, dogs are able to use cross-modal sensory integration to take in the visual cues and auditory, like the sound cues. Because of that, they're able to categorize emotions. And then another question that came up, like, are dogs like trained to do this, or can they just do this naturally? And the dogs in the trial, they trained beforehand to recognize emotions. So we can kind of like make an inference that dogs like have this innate ability to do so, like they're born and they're able to do so. Or they like learn to do it as they grow up, and it's not like taught by humans, which I think is like really interesting because like how did this happen? Why did this happen? And then finally, the dogs were better at recognizing like emotions in other dogs, and one theory is that they're just better at this because they've been like evolved like around other dogs, like Alaric. But then my question was like, how? Like, why did this? Like, how? And so here are just some like theories that were presented in the paper that I thought were really interesting. Dogs are one of the only species that has like interacted with humans and like integrated into society. So maybe they've evolutionarily evolutionarily been able to like do this because they've been around humans so much and they've kind of evolved to be able to do so. And the second one is that they're social creatures. Well, I don't think my dog is a social creature because she hates like everyone, but if your dog is a social creature, it's probably like advantageous and useful to it to be able to like recognize other organisms' emotions because it's around them so much. Again, he's not a social creature. Finally, there was this concept of not like natural selection, but kind of human selection, where like maybe humans had like bias towards dogs that were better at recognizing emotions, so they like unconsciously bred the dogs that were better at recognizing emotions because they were like the supposedly better dogs, and that's why we have now dogs that are really good at recognizing emotions because of this kind of human bias in the past. Okay, and then there was like previously debate whether dogs could even recognize emotions after all, so that's why kind of the study was so revolutionary because it proved that they could take in like multiple sources of information and then determine like this is like the correct face because the emotions match up and like this is the emotion. And so there were like other experiments where they could tell the difference between sad and happy faces, but there's a difference between like recognizing objects and kind of understanding what they do. For example, you could like tell me like the apple is red, and then every time I saw a red apple, I would be like, that's an apple. But I would never understand like on a deeper level like what the apple tastes like where it grows. I would never be able to like apple on a deeper level. So there was no previous study showing that dogs really understood what emotions meant, and there was no like previous study showing that they could do it kind of with two sensory modalities. So that's what this study proved, which I thought was really interesting. Okay, so I'm just gonna leave you guys with like a final takeaway, and then we can open questions and discussions. So your dog is able to recognize your emotions if you even have a dog. And this is a cognitive ability that we thought like only humans can have. And like, what kind of new research does this open up for the future? Like, if we brought in, I don't know, like, what's like can somebody give me like a super random animal?
Capybara.
Yeah, a capybara. So if everyone had a pet capybara, and they just were like walking their pet capybara all day and like feeding them, and like it was just like normal to have a pet capybara. I really love capybaras, by the way. So would capybara develop the ability to like recognize emotions? Would they be able to look at us and think like, oh, she's sad or she's mad or whatever? And then or is this kind of like an ability that's like unique to dogs? Like, I think this opens up a lot of new pathways for research and also like cognitive research. So yeah, thank you.